All right, ladies and gentlemen, the next part we're going to go into is adding and subtracting rational expressions. We've already talked about basically how to multiply, how to divide, how to reduce, um, and it was all just like we did with regular fractions before, right? Well, this next part is exactly the same thing. You are you're basically going to treat them just like normal fractions. So what would you do in the case, say you had um, 2 over 3 plus 4 over 3, right? What would you do in that case? You would add the numerators, right? And the denominator would stay the same because the denominators are the same, right? So you leave the denominator, you add the tops, so 2 and 4. That means we have 6/3. And then what do you do from there? You reduce, right? So you know that 3 goes in to both 3 and 6. 3 goes into 3 one time, 3 goes into 6 two times, and you end up with just 2, right? Well, it's exactly the same thing when you are adding rational expressions. The only difference is now, instead of having simple numbers like that, you now have things that are a little more complicated. Not a lot more complicated, just a little. So like the example they have here, they have 4m over 3 plus 5m over 3. And basically, our denominator here is exactly the same as we had right above, right? So denominators are the same, so the denominator stays the same. And then you just you just take your sign and apply that to the numerators, right? So you got 4m plus 5m. So 4m and 5m's, that's a total of 9m's. Okay, and then what do? We have to reduce, right? So we have the 9 and the 3. Those two reduce. 3 goes into 3 one time, 3 goes into 9 three times. So we end up with 3m. And that's it. Really, adding is really simple. Okay, especially when we have like denominators. Next part, after the next video we'll have unlike denominators, so that'll be a little more difficult, but you get the idea. Okay, let's do another example here. Alright, so the next example that we have, changing colors here, hold on just a second. Sorry, the next example that we have 6a squared over a plus 2 plus 4a squared over a plus 2. Okay, this is on page 6 of your notes for Unit 7. Alright, so our denominators are the same, so we're just going to keep those, just like you would in a normal fraction. And then 6a squared plus 4a squared, that gives us 10a squared. And there's nothing we can factor out there, there's nothing we can do, so we're just done. That's it, that's your answer. So 10a squared over a plus 2, that's your final answer. Alright, so example 3 gets a little bit harder. So we have 2x squared plus 3x minus 7 over 2x plus 1. And then we're going to add that to x squared plus x minus 8 over 2x plus 1. Okay, our denominators are the same. And so what do we do here, right? We just combine like terms. Okay, so our first like term, we have 2x squared and x squared. Okay, and our denominators stay the same, sorry, 2x plus 1, so we got that. So 2x squared and x squared, that's going to give us 3x squared. And then we have 3x's and another x, so that gives us plus 4x. And then we have negative 7 and a negative 8. That gives us minus 15, right? Now, if you look at that, it looks like, okay, we're done, right? But the problem is here that we can actually factor that down, right? So that top part, 3x squared plus 4x minus 15, can be factored. And so we got to make sure you factor that down. And when you break it down, it's already done there for us. We have x and 3x, okay? And then to put them in together, we use a plus 3 and a minus, not a minus 15, we do use a minus 5. Sorry, got a little slip of the wrist there. 3x minus 5, and that's all over 2x plus 1. Now, in the case that we did have something that was alike, so say one of those did end up being 2x plus 1, then you'd have to cross cancel, right? Okay, so you'd have to reduce. There you go, and that's all there is to addition. Okay, and now let's talk about how we subtract. Okay, so when we're talking about subtraction, right, basically it works the same way. What happens is the sign there, okay, the minus goes with the numerator, right? So you apply it to the numerator. So it's like saying 4 over 3 and then negative 2 over 3, right? And so 4 minus 2 would give you 2 over 3. Okay, now the reason I show it to you like that is because you're going to need to apply that negative to the numerator of the second one, and then you have to make sure that you apply it to every single part of the numerator. So basically you're going to be distributing the negatives, what you're doing, okay? So let's take a look at the example they have here. They have 3a over a plus 2 minus a minus 4 over a plus 2. Okay, so again, okay, our denominators are the same. But here what you want to do is you want to take this minus and you want to distribute it inside of the numerator for the second term. So basically when you rewrite this, you're going to rewrite it as 3a minus a plus 4, right? Because the minus a, so minus the a is negative a, and then minus negative 4, that becomes positive 4, right? And then over a plus 2. Okay, then you combine like terms, 3a minus a, that's going to give you 2a plus 4, all over a plus 2. And are we done? We're not, because we can do what? We can factor out of that top one, right? So the top part, I'm going to go back to white here. The 2a plus 4, you can pull out a factor of 2, right? So you pull out 2 times a plus 2 over a plus 2. And look at that, we can cancel the a plus 2's, and we're just left with 2. There's your answer. Okay? So it's a pretty simple process. You just got to remember to distribute that negative. Okay? At the bottom of page 6, there's a couple try these. So give those 2 try these a shot and see how you do. Alright, so the first try these, you got 4m plus 5 over m minus 1 plus 2m minus 1 over m minus 1. So we just combine them, right? Combine like terms. Bottom stays the same, m minus 1. 4m and 2m, that gives us 6m. And then 5 and negative 1 gives us 4. So we can factor out, right? We can factor out a 2 out of the top. So this becomes 2 times 3m plus 2. I need to shrink that down just a hair. There we go. 3m plus 2 over m minus 1. And I believe that's it. We can't do anything else. There's nothing to cancel out, right? So we are done with that one. Alright, and the next one. This one's going to be a little work. We have 2y squared plus 4y minus 3 over, that's an ugly 2, sorry, over y plus 3 minus y squared minus 2y minus 12 over y plus 3. Okay? Now, we want to make sure, right, we have that negative and we got to distribute it to everything inside of here. Okay, so it's going to go to all 3 of them. So we have, I'm just going to kind of combine them and switch them at the same time. So on the bottom we have y plus 3, right? Now on the top we have 2y squared plus 4y minus 3. Then we have minus y squared plus 2y plus 12, right? Okay, hopefully you're following along. Okay, next step. We combine like terms, so we have 2y squared and a minus y squared, so that gives us just y squared. And then we have 4y and 2y, that gives us plus 6y. And then negative 3 and plus 12 gives us plus 9, all over y plus 3. and it looks like we have, we can factor there at the top. Okay, and hopefully you realize that that is a trinomial square, right? Okay, if not, hopefully you just realize that you can factor it. Trinomial square, basically you take the square root of the last term, 3 and 3, right? So this becomes y plus 3 squared. I'm going to write it as 2 of them just so I can show my reducing. And look at that, those two cancel, and we're left with y plus 3. Okay, hopefully that makes sense to you guys. Go ahead and do all the work that goes along with it. Hope that makes sense.